Welcome back to our AdBlue production series. In the previous episode, we placed our first equipment and started building the base of our factory unit in 3D. Step by step, we are transforming the PNID into a real virtual plant. Today, we continue developing our production line, and I will show you the next important components, explain why we add them, and how they should be connected in the system. The goal is to make this process clear, practical, and understandable even if you are just starting learning plant design. So let's continue and build the next stage of our AdBlue production model. As you see, I connected 2 pumps and a filter to the reactor. The principle here is very common in real factories. We have 2 identical pumps. One is working and one is in reserve, so if the main pump fails, we can switch over instantly without stopping production. These pumps take the solution from the reactor and send it through the basket filter. This filter will remove mechanical impurities from the AdBlue solution, so the quality stays consistent and stable. Later, we will add pressure indicators on both sides of the filter to monitor when the basket inside needs cleaning. This small logic of redundancy, filtration, and monitoring is part of reliable plant design, and you will see this many times in different industrial units. Now I am ending our suction lines with isolating valves and drainage valves. These valves are important for maintenance and safe operation because we need to be able to close the line, drain it, and work without shutting down the whole system. The next step will be to place our storage vessels, where final AdBlue product will be stored. In this design, we will use 4 vessels. They will be slightly smaller in size, but using multiple units gives us flexibility, easier maintenance, and we can rotate vessels if needed. I will use vertical vessels because this type saves floor space and is widely used in real installations. Each vessel will have a simple discharge nozzle and a fill nozzle, so we can easily fill them from production and discharge product for loading or recirculation. Let's speed up this vessel placing work. Here I place the vessels very close to each other because in this unit there is no need for a person to walk between them. But in real installations, depending on the client requirements and maintenance philosophy, you may need to leave larger spacing between vessels. For example, 1 meter clearance between vessels is a very common safe distance, and same rule usually applies from vessel to wall. Always think not only how to fit equipment in the model, but also how people will service it, open manholes, connect hoses, or inspect nozzles. These are small layout decisions that make a plant more realistic and maintainable in real life. All vessels are now in place, so the next step is to create our filling collector. The idea is simple. We will bring all 4 vessel fill lines into one common collector pipe. This makes the filling process easier, cleaner, and more organized. From one main line, we can distribute product into any vessel we want. In real life, this also helps to reduce the number of valves, pipe spools, and welding work. It also looks cleaner in 3D model and is easier to control during operation. So now let's start routing this collector and connecting our fill nozzles to it. Now it's time for some more copy work. Let's add valves to each inlet line leading to the vessels. The principle is simple. All nozzles remain closed by default. When you want to fill a specific vessel, you open only that nozzle. This can be done manually, where personnel open it by hand, or automatically, with the operator controlling it from the computer in the control cabin. Once the valve is open, the filling process begins. Let's connect this collector to the pipe discharge line. When you get used to working in 3D, the process becomes natural and not boring at all. You'll find yourself selecting all the parameters almost automatically. Let's speed up this part to see the result. You might notice that I often move the view around from different angles. It's not just for fun. This habit actually helps me visualize the model better and understand how everything connects in space. By rotating the view, I can spot small alignment issues or clashes that are easy to miss from a single angle. Over time, this becomes natural, almost like walking around the real installation in your mind. Now let's add some standard discharge line components, a check valve and an isolating valve. These are essential parts of any pipeline, ensuring one-directional flow and allowing maintenance or shutdown when needed. The check valve is necessary to prevent the liquid from flowing backward when the pump stops or pressure drops in the line. Without it, the fluid could return from the vessel back into the system, which might cause contamination or damage to the pump. So, it's a small but very important safety element in any discharge line. Here I'm adding ball-type isolating valves. Butterfly valves could also be used. Both serve the same purpose of shutting off the flow when needed. The choice usually depends on pipe size, pressure, and operator preference. The next step is to place the second filter. The first one we added was a coarse filter used to catch larger particles. This second one is a fine filter. It ensures the final liquid is clean and free from any small impurities before going further in the process. We can use the same type of filter housing, but keep in mind that the mesh inside this filter is different. The mesh size defines how fine the filtration is, so even if the filters look identical, their function in the process can be quite different. Let's connect it to the main line. I often use intuitive 3D modeling when creating pipes. It helps me connect everything much faster and more comfortably. You simply indicate which parts should be linked, and the software automatically builds the connections. Just one small fix in our water line, and then we'll get back to the collector line. We need to have the option to either recirculate the water or pump it into the reactor. These two valves make that possible. By switching them, we can easily choose the desired flow direction. I'm copying the pipe to keep the same coordinates, just placing it a little bit lower. Then we simply stretch it and connect it to the vessels the same way as before. I already see a mistake. I didn't leave enough free space for the valves. It's a small detail, but important to fix now before continuing, otherwise maintenance later could be difficult. But it's always better to find a problem in the 3D model than on the construction site. Here, fixing it takes just a few clicks. Out there, it could mean hours of work, extra cost, and a lot of nerve cells. The idea is to have all the valves grouped in one place, so the operator can control them comfortably and efficiently. Usually, we place them close to the main access area or control platform, where visibility is good and movement is easy. This setup also helps during maintenance. You don't need to walk around the whole system to open or close a single valve. Everything is in one zone, clearly labeled and easy to reach. Imagine how uncomfortable it would be to open a valve that's 2 meters above the floor. You'd need a ladder every time, which isn't safe or practical. That's why proper valve placement is so important. It saves time, keeps the operation safe, and makes the operator's job much easier. Okay, we already have the vessel emptying collector, but we don't yet have the equipment to take the product from it. So now we need to add a pump or another transfer unit to move the liquid further in the process. As I'm watching this creation process, I realize I could simply take the whole pump block, copy it with all the valves, and just rotate it. But maybe at that moment, I was thinking a bit differently about the layout. Our pumps are hanging in the air for now, but later we'll create a proper support, either a metal frame or a concrete foundation, to place them securely. That's a typical step in early design, when the main goal is to define positions before building the structure around them. These suction lines have strainers that look a bit different. Each one is designed for a specific purpose, to protect the pump by catching any particles or debris that might come through the liquid before it reaches the impeller. So that's it for this part of the AdBlue project. We've added the valves, filters, and pumps, and made sure everything follows the proper flow direction. Step by step, the system is taking shape, and soon we'll have a complete, well-organized model ready for operation. Thanks for watching, and see you in the next episode.